Let us see implementation of queue using linked list. So basically the design picture is that we have a singly linked list, null terminated at the end, and we have two pointers. We have the front which points at the first node, and we have the rear which points at the last node. So we could have done with one node also, one pointer also, but then inserting at the end would be costly. It would be order n. So that's why we keep this rear pointer, so that insert at the end, which basically means the NQ, can be happening at order 1. So that's the thing, and let's see. So we understood front is first node, rear is the last node. So if we consider is empty and is full, is empty condition is front and rear both are null. So the linked list is empty. Full, it never happens. Is full never returns true. Basically the queue gets full only if the RAM is exhausted. So when we dequeue, we take out a node from the front. When we enqueue, we insert a new node like this. We simply allocate a new node. We do a malloc and we connect the pointers like this, and that's a enqueue, and then we move the rear also, that the rear is here now. So that's how it happens. So basically we are talking of insert at end function and delete from begin function. So if we look at the code, here we have the code in the data structure using C repository and queue, and you can go to list implementation. There are successively 4 implementations, so we will see that. So if we look at the first one, queue, let me open it in the other terminal here. So let's look at the first one. So it is basically what I have, it's actually only the linked list code. We have the linked list node, we have delete from begin, which I have renamed to dequeue. That's all. Head I have renamed to front, and insert at end I have renamed to NQ. That's all. I have only renamed things. So it is a plain vanilla linked list code. The flip sides of this linked list code is NQ is costly because this while loop making PTR reach the last node is a order n process. The other flip side is that when we delete from begin, we are not returning the value. What was the value in that node? When we dequeue a element, we need to get the element in our hand, that this is the element. So the next version, q2.c, just fixes this problem that dequeue returns the next element. So let's look at q2.c, and if you see dequeue, it has got this addition int star p lm. Basically we wanted to return the int, so we took pointer to that and we are setting it here. Why we couldn't use the return data type? Because the return data type was used to return the modified front. So that's why we couldn't use the return data type to return the element. So this you can consider as a output argument. We took pointer to some argument, and via that we are returning that thing. So this is the only change in q2.c, which is not much. The main problem of NQ being order n due to this while loop still remains. Let's consider the next version, q3. Here what we have done is we have defined like an abstract data type q underscore t. Basically you can say that the q is comprised of 2 pointers, front and rear. So we created a data type, and this data type is the pivot element which we pass to each function. If we have to display, we give pointer to this structure. If we have to NQ and DQ, we give pointer to this structure. There is another approach also. You can simply say that you will not encapsulate front and rear into one structure, but you will pass them separately. So thinking in a naive manner, you can say that I will pass the front pointer and I will pass the rear pointer. So that is good enough. You are passing front and rear to NQ, that's good. But the problem is front and rear will change as part of NQ. Both can change. So how do you manage that? In a singly linked list, we manage by returning the resultant pointer, but there are two pointers, front can change, rear can change, you can only return one pointer. So how do you manage? So if you are doing this passing separately approach, then you need to pass pointer to pointer, because the rear can change, the front can change. So you pass pointer to rear, that means pointer to node T star, and pointer to front, that means pointer to node T star. So node T star star. So this is also a fair way of doing things. It's not bad. It's just that I chose this approach. I encapsulated in a structure. So the q3.c is not a compilable code, but I have just ironed out the prototypes. So when you say dq, you need to return that value. For nq, you take the q and the value, and it returns success or failure. So for linked list, it will rather always succeed, because for array it can fail. For array it can fail because if the array is full, it will fail, but linked list never gets full. So this success failure is not really that important. I have kept it just to be symmetric to the dq, because dq can fail. If the queue is empty, then dq can fail. In fact, yeah, so I think this code is under progress. Ultimately it will return success failure or something like that. So let me open the next version and let's look at dq in the next version, which is the actual correct one. So if you see the dq, the finally polished prototype, it returns success failure, and if the queue is empty, it returns failure. And how does dq return the element? It returns it via the output argument. So that is how it is. And how do we actually enqueue and dequeue? So basically there is this pseudocode which I have worked out. For enqueue, you allocate a node, you fill the values, and then there are conditions. If the queue is empty, then both front and rear point to that node, and we have a single length queue now, and that's enqueue. So I think this free the node doesn't belong here, it is wrongly written here. So this is the code. That was for something else, I mistakenly written, sorry. And if the queue is not empty, so basically it's a good idea to always think in pictures. So when we think in pictures, ultimately there are three cases. I will just indicate. There are three cases which we need to handle. One, a queue having let me use that. The first case is a queue having more than one node. The second case is queue having a single node, and the third case is totally empty queue. So the pseudocode, if we see for enqueue, so we allocate the node, and if the queue is empty, then basically we point front and rear to the same single node. Otherwise we attach the new node at the like I had shown a couple of minutes ago. We attach it at the end and we ground it, so like that, and we have to move the rear to this thing. Okay, this free the node, again it had to be written somewhere else. That's a mistake. I had to write it somewhere else. So anyway, so that's enqueue. And if we see the code also in the enqueue, it is quite very much corresponding to the pseudo code. We allocate the node, we fill the data and make it the next pointer as null. If the rear is null, if rear is null, front will also be null, and if front is null, rear will also be null. So they always are null together and non-null together. So if it is empty queue, then we make front and rear both equal to the new node. Otherwise we attach the new node as the next of the rear, and we move the rear to the last node, and the next pointer of last node was already set to null. So that's NQ. And DQ, similarly you can reason. DQ you have in fact three cases. If you try to DQ from a empty queue, then you should give an error. If you DQ from a single node queue, then you should make front and rear null. If you DQ from a more than one node kind of queue, then what will happen is you will delete this node and front will start pointing here, rear will not change. So accordingly the case is written, if queue is empty you return failure, if queue is a single length queue then you get the element, fill the return value, free that node, and you set everything to null, because after deleting the single node the queue becomes empty. And if the queue has at least two elements, you take the data from the front and you move the front to the next, but before moving front to the next you need to store a PTR to the first node so that you can free it, right? So we stored a PTR to that front, and after moving front we just freed that memory. So that's DQ. And as I said, broadly that's the code. Is empty and is full. Init also is a method. You can initialize. How do you initialize? You set both to null, so that's a empty queue. And okay, we have not written is empty and is full here, but you can imagine is empty would be like checking whether front is null or rear is null. Is full, it will never be, it will always return false in case of linked list based implementation. So linked list based implementation, it gets full only if the memory is exhausted. So that's the implementation using linked list. It is quite similar to simple linked list, except that instead of the head we keep head and tail, you may say head and tail, or rather you call front and rear. And you just need to be careful about the different conditions, one node, zero node, or more than one node. So if you take care of those conditions well and you work out the pseudocode well, then possibly you can simply copy paste the pseudocode in the code and you can mature it. So this approach of thinking in the pictures first, then writing the pseudocode, then copying the pseudocode to the code file, and then maturing it. And some of the pseudocode may become a command, some of the pseudocode may become actual code. So that is a clean way of writing code.